Hi, welcome to a Teardown Tuesday. We've got a random bit of old test instrument kit here. Look at this, Systron Donner counter timer. Hands up if you remember Systron Donner. They're actually still around, but they don't make test instruments. They're like a defense company who make like radar-y type things or something like that these days, I think. Anyways, it's a 6051 for those playing along at home, counter timer, and look at this, all these manual range buttons, beautiful. And yes, it's not just a frequency counter, it is, as the name says, it's a counter timer. So you'll see start stop here. I don't know what these start stop thumb wheel switches. I love thumb wheel switches. I could play with those all day. And they're probably like some start delay or stop delay or something like that perhaps. I don't know. I don't have the manual for this to hand. And it's got AC/DC coupling on all the channels, attenuator of course, your thresholds and your various functions. You've got, you can do a count, would be not frequency counter, but physically counting your inputs. So, you know, this is very handy for counting events and stuff like that. If you don't have a proper timer counter in your lab, highly recommend you get one. If you want to count how many events happen, transitions happen in a certain time period or something like that, counter timer is absolutely invaluable for doing something like that. And of course, it's frequency counter, and you can get period and frequency display as well. And this is actually a Nixie tube display, as we'll see. Hang around for the end, we'll power this baby up, and sure, we can get some Nixie tube goodness out of this thing. Hopefully, that's the plan. Anyway, this one has seen better days. Look at the top on that. I'm sure it didn't come factory fitted with that moldy type camouflage. I'm sure it's you know, it hasn't aged well. This probably dates from, you know, sometime in the 70s. It's definitely not 80s because it's a Nixie tube based thing. None of that LED display rubbish. So let's have a look. On the back here, we've got external reset, the IEC mains power input, BCD out, a remote control interface, and it looks like we've got an ovenized oscillator here. If we take that cover off, I'm sure we can get into and adjust our oscillator there. Fantastic. It's got all your external time base and stuff like that. But the most interesting thing, assembled and tested in Australia. No wuckers. Well, you know what we say here on the EEVblog, don't turn it on, take it apart. Okay, this one's going to be way too easy. 2 screws in the top. Let's pull it off. And, oh, sorry, I'm going to have to move the camera back. Whoa, we're in. Oh, isn't that beautiful? Oh, look at the daughter board, vertical, you know, motherboard construction with all the individual cards popping out. Oh, that is gorgeous. Oh, wow. Oh, there's some system design engineering gone into this puppy. I just love it. And look at the gold-plated PCBs down there. Oh, yes, sirree, Bob. Oh, none of that tin plate rubbish. Japanese fan. All the best stuff's made in Japan and Australia. Oh, there's our ovenized oscillator down there. Check out the back of that. They've got, like, you know, an old-fashioned tube socket, and just discrete wiring just bundled out. Coming, of course, to the rear because you want to, that was like the external frequency input and stuff like that. So you want to be able to switch between those. So got one big folded metal like cage at the back that holds all the power supply, fan, ovenized oscillator, some of the big ass filter caps here. And it looks like some more big ass filter caps in there. And these are probably, oh, your power, look, little test sockets. Little test sockets on your power supply. Ah, oh, beautiful. And then the rest of it is just one huge board, and that looks like really thick as gold plating on that. Like, you know, gold was, well, I don't know, it was cheap in 73. Anyway, it goes through cycles, really. But yeah, like the old school stuff, they just applied it thick as back in the day, and even like the gold plate that you got on the card edge connectors, you know, they don't make them like they used to. Anyway, this is fantastic. Oh, that's actually an extender card. Wow, look at that. We get a free extender card. Wow, I wonder how much gold's on there. That's sweet. And of course, these extender cards, absolutely vital when you're testing and, whoa, let's get one out, testing and repairing these, because it means that you can just whack it in like that, stick your board on top there, and you can access the front and the back side to probe and troubleshoot this whole thing. So repairability on this, brilliant. Now I'll just go through each board briefly one by one. This one's a bit how you doing. We've got a, is that a tranny there, just bolted onto its own little heatsink. Only single-sided this one, so this one doesn't look the least bit impressive. And we've got tin plate on the bottom here, so they would have masked off during the wave soldering. They just masked that all off and just rolled. Unfortunately, is that hand done? By the looks of it. Anyway, that one's a little bit how you doing, but let's go on to the next one. This looks more like it. Look at this. A little custom-made transformer in there. Look at that. I love it. And by the way, yes, we do have our date codes here. 1973, but some of them have got 72, but at least it's at least 73. So there you go. Look at this. We've got a big ass 10-turn trimmer there. And another, that would be an adjustable capacitor frequency trimmer. So I'm not sure what that is. It's obviously, you know, it's not the main oscillator. So anyway, I love the test points on there, really old school. And once again, it's all tin plate on the back with real thick as gold plating. Gorgeous. So it would have been really nice if these were all labeled. Anyway, this one's the next one in the series there. You can see we've got some inductors there, just, you know, air cord jobs, and not much else doing there. A couple of trimmer caps, little tranny, old school package, beautiful. And look at that, that one's actually got selective tin on it. So yeah, I'm not sure what happened there. That one didn't need much layout time, did it? Little resistor packages. Well, you know, why not? Hey, when you've got a bus system like this. The A7 board, ITT. Anyway, no idea what they are. Yeah, what do we got? A8 board, every board's a winner. They are labelled. It'd be really, you know, I'm sure the manual for this thing is absolutely first rate, and it would list all the different, you know, boards, and it'd have block diagrams and probably, you know, almost certainly schematics in it and stuff like that. But what do we got? It's got, once again, ITT stuff. Oh, 936. Yes, that's old RTL stuff, isn't it? Some of the really early stuff. Anyway, some Motorola stuff. So we're talking, you know, 73, probably late 73 this was manufactured, thereabout. This one's just got logic. All they're upside down, so all the electrons are going to fall out. And you'll notice that there's, you know, NAF4 bypassing on each individual chip. None of that rubbish, just some bulk decoupling for the card. And, you know, that's fine. Gets the job done. And the A10 board is blue because, well, blue makes it go faster. Once again, we've just got all logic. We've got a few more bypass caps. Oh, I love the little SE. They would be, no, are they? I was going to say, no, they're not power because, you know, you can see the power up the top. They're just snaking one into the other. So that looks like probably a ripple counter or something. Not even looking at those part numbers. Can't see them from here. And here's the A11 board. We've got some more analogy stuff, so maybe we could be talking some of the input type stuff. Maybe we've got some AC coupling and stuff like that. I don't know. So looks like we've got a relay there, little read relay job going across. A12. Once again, we've got Motorola parts. We're probably going to see classic Motorola. Motorola just owned the market back then. What is it, the 1309, is it? That was basically the input prescaler in every, I've probably got that number wrong. Anyway, in every frequency counter do-it-yourself design back in the 70s and right through the 80s and probably even into the 90s. Okay, so we just went through in sequence on all of those. So let's pull out a couple of other random cards here. Power supply first. Hey, check out the penetrators going through there. They're going through from the, that's very nice. They're called penetrators because they penetrate a chassis from when you solder on one side to the other. And they're just going through from the folded metalwork up here down to the main board. That's just your power coming over. It's the A13 power supply board. So yeah, what do we got? Just, you know, some classic, 723 regulators. I don't know, not reading the part numbers. And we've got, of course, 5 volts for all your TTL stuff, plus 12, minus 12, and minus 5.2 for your, what's that, ECL stuff. Oh, look at this. We have our first bodge. Check it out. And you can see the, still see the flux residue on those joints. So someone's had a crack at that. Someone's had a repair of the old power supply. Not sure what that board's doing, but it's got pre and balance there. So I don't know. Bueller. None of this wasting, you know, gold if you don't have to. Just love the attention to detail on the links here. Look at this. So they, you know, person laying out the board went, oh, bugger this. I can't get this trace over to here. Why not? I don't know. They could have snuck it around there and went to there. But anyway, well, maybe they didn't want to break their ground in there, but is that big a deal? It's going around there. Anyway, is that a layout fail? They could have bought that around there. Anyway, decide to use a link. And then, of course, you don't want to short out. You know, someone's handling the car, squishes it down, and it makes contact with the gold down there. There's none of this newfangled solder mask rubbish. So they put the plastic sleeve on there. It's beautiful. Oh, that one's getting a bit interesting. Look at the reed relays down there. Fantastic. And I don't know what the rest is doing, but when you see sort of like a symmetrical layout like that, put a line through the middle there, you can see it's completely symmetrical. These are trannies, little transistors either side. When you've got a symmetrical layout like that, you can tell that that's a some sort of differential, you know, line, differential amp, things like that. Anyway, it's, you know, when you see symmetry, you know it's differential. And then, of course, the resistors at the end are going to be across the differential line. And then, so it's probably, you know, like single-ended differential converter, maybe. There's a lot of trannies in there for that, though. And another identical board. So given that there's 2 of them, and also given their placement near the front panel, physical placement near the input connectors, here for like, so this is basically, so this board that we looked at here is A16 one. The input amp for the, like the frequency counter input, the channel A input, and then these 2 boards here, which are absolutely identical, are no doubt the input amps with the selectable AC coupling and the trigger threshold and the attenuation and stuff like that. So there you go, little trimmer pot. Oh, I just noticed that on the back side there. So don't know if it's an afterthought, but there's our, they wanted to ground the input to the chassis here. So when you plug that in, that just makes contact with the chassis. So there you go, that just makes sense. And of course these 3 long boards over here with all the digital stuff, that's just all the different modes and stuff like that. So that'd contain the gating logic and all that sort of jazz. And last but not least, well, second last, let's have a look at this board which handles these thumb wheel switches here. And this is pretty how you doing. I mean, look, you know, like everything else is quite neat and tidy. This just looks a bit messy with the ribbon cables and just the dicky little turret connectors up there. Yeah, they just sort of let it down a bit there, but anyway. Unfortunately, this board doesn't come with the ejectors, and these boards do require, by the way, a lot of force to get these in and out. So I don't want to, gotta tear my fingers apart if I'm trying to like sort of rock it out, but geez, it's really stuck in there good. So forgive me for not taking that one apart. Anyway, that just handles the, that's just decoding for the thumb wheel switches. Now's the time for all you Nixie Tube fanboys to get excited. What we've got here is, these are just latches that latch all the data. 7475 4-bit latches there. But what we're really interested in is down here. Let me flip this around. Oh, there we go. Nixie Tube goodness, 74141 drivers. The absolute classic Nixie Tube driver. And they've put those in sockets because presumably, you know, they could blow. And look at these National Instruments Nixie Tubes. 7328 date code. So, yep, late 70s, late 73. This would have been manufactured. Oh, look at that. That's the money shot in 4K. And then that little board there is just the indicator board for the various, segments like, microseconds and milliseconds and stuff like that. So, gate in and all that sort of stuff, just lights them up. So it's interesting that all this comes in via these dipped cable-tied sockets here. It's not the best choice. It's not quite how you're doing, but it's getting there. And the Sprague capacitor fanboys go wild. Look at that. And it's none of that silkscreen rubbish. Oh, I wish this was field of vision. They're etched in there. They're actually etched, punched in there. Brilliant. You didn't think I wasn't going to show you the bottom side, did you? No, it just lifts off. Beautiful. Oh, look at that. Wow. What a Bobby Dazzler. It's lots of point-to-point stuff there. They didn't, they went to the effort to do the main motherboard in here, but they sort of went, well, we can't do everything, so let's just wire everything over. Labour's cheap, no worries, everything's still wired. Cost really wasn't a huge issue here, so there you go. There's the big capacitors down there, the huge lugs on them. Look at that. Fantastic. What have we got up the front here? Oh, is that a new switch? That looks like a new switch. I reckon someone's bodged in a new switch to there. What do you think? That looks like a new C&K jobby. I reckon someone's had a go at that. Anyway, you notice, look, attention to detail. They put the heat shrink over the big strap going over to the BNC on the front. Geez, they're serious there, aren't they? Geez, that could carry some amps. And this is a double-sided load. We've got 2 reed relays on the bottom. This is fantastic, though. Wow. There's the rest of it. Oh, there's our power trannies on the heat sinks down in there. There you go. Straight into those. Okay, so they're using those penetrators were actually sockets. Yeah, they're actually not so much penetrators, they're actually like transistor sockets that are designed to mount into, chassis with bottom point-to-point wiring like this. I'm sure that heatsink compound is dry as a dead dingo's donger. Yeah, I think I'm right. It's drier than a dead dingo's donger. Well, they certainly don't make them like this anymore, do they? And also, this is the first time I've probably ever seen supplying an extender card. Because obviously, they actually went to the effort to put like a little metal thing to retain it so it doesn't flap around in the breeze and fall out because it's got no socket to go into. So I think, it deliberately comes with that, although you don't get one for these bigger ones, which is a bit of a bummer, but geez, anyway. That's fantastic. Yeah, not exactly cost conscious on the design of this thing, but yeah, it did the business. There's only one thing left to do. Let's power it up. See if it still works. 1973. Confidence is high. I repeat, confidence is high. All right. See if this thing works. Whoa, hey! Oh, look at the beautiful Nixies. Oh, what a Bobby Dazzler. Oh, the power switch has seen better days. It rotates. Fantastic. Oh, look at that. Thing of beauty is a joy forever. And I just love how you can see the 6 poking out further than the 0 because the 0 is physically towards the back on the Nixie tube. So you can really see the difference there. Fantastic. Check out the update rate on this baby. Look at that. They're going so fast you can't see them. Woo! That's counter mode. Wow. That's fantastic. This thing looks like it works a treat. Well, she works. Check this out. I've set it to rate A here and got it set to 1 kilohertz range. So 1 hertz resolution here, generating just a 1 kilohertz square wave here, and it's bang on. But look, you've got to press the manual reset button. It doesn't work. Like if I just suddenly, take that up to 10 kilohertz or something, it doesn't work. We have to actually reset the counter each time. Oh, fantastic. Old school, but it's bang on. Oh, look at this. Look at how fast that counts. That's beautiful. Oh, this is so satisfying to use. Oh, you just want to press that reset button all day. Really, that's just beautiful. But it's out. But which one is out? The Systron Donner or the Siglent, this newfangled Siglent? Ah, it's time to bring out the big guns. So we've got the CSIRO frequency reference standard. Let's take a look at this. Rubidium locked. Ah, there you go. She's out by 82 hertz. Oh, bummer. And we can actually extract an extra digit from this if you want to go overscale. I love the fact the manual reset just lets you show. It's a really good visual way of showing the gating period. In this case, it's going to be 10-second gating period, and how it actually counts those 10 megahertz pulses in that counting period. There we go. Oh, it counts the input pulses. Sorry. If we're in reciprocal counting mode, then it would count the input. It would count the reference clock pulses. But there you go. 826. Oh, that's slightly different, isn't it? To what do we have? Oh no, 82. There you go. So it was actually 826. But yeah, it's beautiful. I just want to use this all day. So I won't go through and test all the functions on here. You know, you'd have to test the start, stop, and the start, stop, and whatever, delay or whatever it is here. And you'd have to test, you know, all the various threshold levels and the coupling and all sorts of stuff. But it seems to do the business. This is, you know, it's not a big, like, 12-digit display like you get these days. It's only 8 digits, but meh, you know, this would have been pretty schmick back in the day. So I hope you liked that Teardown Tuesday. If you did, get a random number there. Please give it a big thumbs up, and as always, you can discuss down below. Catch you next time. What will the random number be? Use this as your lotto pick. Alright, I know people aren't going to be happy unless I tweak this thing to match my rubidium, so here we go. Alright, I think I got it. Tongue at the right angle, very important, so none of this live updating rubbish. Wow. Geez, what is this, a 10-turn trimmer? I think I'm turning it. Hang on. Okay, smaller screwdriver this time. Geez, that's gone all the way with LBJ. Let's turn it all the way the other way. Yeah, it's like a 10-turn, 5 or 10 turn. I got diddly squat. What? Oh, 69. Nah, I've gone all the way. I'm not getting jack. What the? So after watching the teardown, I realized that it did have an internal 10 megahertz oscillator and adjustment pot on that board, if you remember that we actually took out. So I figured that the ovenized oscillator that we saw in the back of this thing is probably like a separate thing, and you had to connect it. So what I've done is actually hooked up the external 10 megahertz out to and switched to the external frequency in, and that's what we get. And it makes no difference when I tweak that pot on the back for the ovenized oscillator. So I'm going to have to damn well cheat and plug my external reference into my 10 megahertz rubidium standard, and of course it's going to be bang on because I'm feeding the same 10 megahertz into the reference clock as I'm feeding into here. So will it make a fool out of me, or will there be one least significant digit? Nah, there we go. And can we go all the way with LBJ up to with our 10-second gating time, and we should get all zeros, maybe a least significant digit. Oh yes, a least significant digit, there you go. Right, so I switch back to the internal oscillator, and here it is over here. So let's tweak the internal oscillator. We've got 60 on there at the moment. Oh no, 71. Oh, why has it changed? I'm going to tweak that a little bit. Yeah, 64. Okay, we're going down. Oh, bang on, look at that. All right, so I can't believe it's got like the ovenized oscillator in the back, and it's set to the internal. Oh, there we go. Oh, I could tweak it maybe a little bit more. Ah, half a bee's dick. Ah, near enough. And if we actually go back and have a look at our ovenized oscillator here, you can see that it is actually all entirely separate. Look, I mean, the middle B and C down in there is the 10 megahertz out. So, yeah, I was doing the right thing by connecting the external frequency input up to there, like that, and then switch in our reference to external. But if I do that, and then do it again, so yeah, I plug that in, and like we're over, which is fine. You know, it might need a trim, but the trim does nothing. So maybe there's a fault with the trimmer inside that ovenized oscillator. So, but it gets stranger. I'm not sure if I'm using this thing right. I've disconnected the external 10 megahertz reference. I've got it switched over to the external frequency standard, and it still counts. What? And that's pretty close to bang on what I did with the, and if I switch it to the internal, back to the internal oscillator, that's what we were getting with the internal that I just trimmed. And it's drifted a bit, you know, temperature. Meh, the internal oscillators aren't great. So yeah, I don't understand this thing at all. It's very strange. I might have to RTFM if I can find the FM. Catch you next time.